Good morning, all. So this is the lecture based on the correlation. So first, understand what are the correlation is there. Suppose we have two variable, let's say x and y. If I want to see if there is some relation is present between the two variable x and y, then we'll call say that okay, there might be some relation is present based on that two variable x and y. Uh, Upon increment, if I increase the variable, let's say we have variable x and y, and if I increase this x variable and there is also increment of this y variable is also there, then we can say these two variables are correlated. Okay, so these two variables are, we'll say, correlated because the relation is present between these two. Okay, now sorry for my this handwriting. Now let's just understand what are the different type of correlation we can have. So we can have positively correlation, means if I increase this x variable, then y also increase, another variable y is also increases. So the correlation is always it is for two variable. Okay, so this is for two variables. So let's delete this one. So this is for always for the two variable. Let me write that thing. For two variable we can find the correlation. Two variable. Okay, now next one is that suppose we have negative correlation. So when suppose I increase x variable, one variable I increase, but another variable y, that is it will be decrease. Okay, so it will be go positive way. If I say, then it will be go the negative way. So another way, if I can say that if I increase the x variable, then y is also y is decrease. Okay, but for this positive correlation, if I increase one variable, let's say if it is going to positive way, then y is also will be positive. So it is also increase positive way. Then if I increase or decrease this one x variable, then y variable also will be decreased. So whenever the change of sign of one variable is also happen, then another variable also will be the same change of variable sign. So one variable if increases, then another will be increases, or one variable decreases, then another variable also will be decreases. So in this case it is known as the positive correlation. And negative correlation is that increment of the other variable will affect the decrement of other variable, then it will be the negative. If the decrement of, let's say, x variable, then the increment of another variable, then it is also the negative correlation. Okay, is it clear? Now third case, that is known as the no correlation. Also it is called, sometimes called zero correlation. Okay, so it is also known as zero correlation. So number third, that is for the zero correlation. So three correlation we can have. One is that positive, and that is the negative, and no correlation. Now let's understand all these different sort of correlation by examples. Now first example, suppose we have uh, this data. So this is for one variable, let's say this is for x variable, and this is the y variable. So what are the data here? So x variable is that one student, the how many hours he or she studies. So if one student studies for 2 hours, then his corresponding grade is 3. If another student studies for 4 hours, then 4 is corresponding grade point of that student. And similarly 6, if it is that hours one student study, then his corresponding grade point is 7, and so on. Now if you see here that if I here x variable gradually increases, so it is 2, 4, 6, 8, 10, so it is increases, and y variable also similarly increases, so it is 3, 4, 7, 7, 9. So I can see there is a positively correlation present. Now if you have lots of more data, you cannot just observing the data, you cannot predict. Also, if the data is not given in the ordered manner, let's say if your uh, first data is given 8 and 7, and another data is given uh, after that 2 and 3. So if the if from the observation you cannot see, so what you can do for this case, you can plot this data x and y, and from that thing you can tell about the data. Okay, what type of correlation is there. So if I plot this data in the xy plane, okay, so this is the x variable, that is the number of hours one student studies, and y is the his or her grade point. Y is the grade point. Now for the first number, that is 2, and the corresponding grade point 3, so this is the first dot, 2 and 3. Next one is 4 and grade point is also 4, next data. Then 6 and 7, 8 and 7, and last data is 10 and 9. Now you see that there is one sort of this increment set of curve or straight line you can see. Okay, so you can basically represent or approximate all the data point by a straight line that is in this increasing way. Okay, another example, so this is basically your positive, because one is increasing whereas other one is also increasing. Another example, let's say if you have this data, so what is the data? So first data is, that is that how many percentage one student absent in a class. So this is that 10%, if the total number is 100 uh, class is there, so means 10% absent means 90 days the student is present. So if 10% absent, that student's grade is 9, and if it is 20% absent, then that corresponding student grade point is 8, and 30% absent of a student grade point is 7, and 40% grade point is the if it is absent, then it is grade point 5, and last one is 50%. If a student is absent, then the grade point is 4. So if I write the first variable y and next variable y, first variable x and next one is y, then by plotting that thing, also without the plotting I can see that if I increase this absentee 10, 20, 30, 40, 50, then there is a decrement of the grade point 9, 8, 7, 5, 4. Okay, so this is, I can see this is basically negatively correlation present. Now I can similarly I can plot this x1 data, right? So I can plot the first variable x data in the x-axis, and another variable grade point, that is the next data, in the y-axis. So first data is 10, 9 here, then 28 here, and 37 here, and 45 is here, and 50 is here. Now I see when I increase this one, then the y variable is value is gradually decreasing. So I can approximate that basically there is this sort of straight line pattern I can see. So basically there is approximation of this negatively correlation or negatively uh, correlation or negative value is present between these two variable x and y. So in this case I can say these two variables are negatively correlated. Okay, now let's take another example. Suppose we have height is that height of a student is that variable x, and the corresponding grade point is variable y for 70 inches. So these are all the heights in the inches. So 70 inches if a student height, then the grade point 8, and 65 inches student is grade point 9. Similarly for other height we can have that grade point is this. So I can see from the data, if the height is decreasing, I cannot say that grade is also decreasing. Instead it is increasing, after that it is decreasing, here again increasing, and here also increasing again. So I can say that if the student height is 50 inches, his grade point 9. Also, if a student height is 65 inches, his grade point is 9. So I cannot say anything. So I can see from this data that there is no correlation present. Now, what happened if I draw this xy data in a xy plane? Then in this case, I can say that for the first variable 70 and 8, sorry, this is the first variable, and next one 65 9, this one, then 65 here, 55 7 here, 59 here. So I cannot see any sort of pattern is present between this variable x and y. If I increase one variable, let's say x, then I cannot see that whether y is also increasing. So there is no such pattern. If I try also to approximate all these points by a straight line, although I can join this point by a straight line, but I cannot draw one straight line to joining the all the 5 points, okay, or near about approximate all these 5 points. So I cannot have a good straight line or base straight line that will approximate all the 5 points. Although I can draw some sort of line, then these 4 straight line will be vicinity of this straight line, but this point will be far away, right? So also I can draw another straight line this way. So in this case, these 4 points will be vicinity of this straight line, but this will be far away. So there is no sort of pattern, or I can see, means if I increase that x variable, then there is no significance of the increment of y, right? So there is no correlation, or in this case I can say that is the zero correlation, right? Now this is all the qualitatively way, means from the diagram I can see if there is some uh, relation is present between the variable x and y. Now if I want to measure this in the quantitatively way instead of qualitatively, then I have to use some tool. So there is already one tools is present, one measure is present, that is by the uh, Pearson, okay. By that way we can find out. So before that, I just summarize all the three cases that I'll find out here. So I have first case, I have if that xy with the plane, then first case I see that positively correlated. So in this case the straight line will be this way. Another one that is negatively correlation case. So here we have the straight line something like that, right? So this is for negative, and first one is the for the positive. Now another one that last one that there is no correlation. So in this case I cannot find a better straight line to joining all these points. So in this case it is zero correlation. So these the three correlation we can have from the diagram also. Now if we have this sort of data, then by the qualitatively way I can measure, right? Now if you see closely, this is basically I cannot see that there is some increment of the x variable, right? If I write this is x and this is the y, then I cannot see there is increment or decrement of the y, right? So this is the same data of the first example that I have just shown. So instead of writing 8 and 7 here, I just write in the first place. So it will be difficult to judge based on the this data. So another way I can judge by the plotting this one, this point. But what if I have some measure? By that way we can find out what is the correlation is there. So that measure is known as the coefficient of correlation, and that is by the Pearson. That Pearson's also defined another measure that we have learned, that is the skewness. Here also learned another measure that is for the finding the correlation. Now what is that measure? So that correlation between the two variable x and y, it is denoted by this letter r. So r is the correlation between the x and y, and it is defined by this way, sum over xy. So this is basically, let me tell you, so this xy is capital Xy, but this is basically small xy, okay. So this is the small xy, and definition is based on the capital Xy. And what is the capital Xy? So capital X is that small x minus the mean of the variable. So small x is this one. So I have to find out what is the mean of this x data. Okay. After finding the mean of this x data, if I subtract each of this data from the mean, then it will be capital of y data. Now similarly, y is also same defined as y minus arithmetic mean of y. Okay, and n is the number of points. So number of point is 5. Okay, 5 points are there. We'll see only for one variable how many points are there. That is equal to, in this case it is 5. And sigma x and sigma y, that you already know, this is the standard deviation of x and standard deviation of y. Okay, now there is one bound is present of this variable r, that is -1 to +1. If the r is +1 exactly, so it will be known as highly correlated. Also, if some cases, if for this data we will find that r is, let's say, very high value, might be 0.98 something like that, then in this case also we'll say that these two data points are highly correlated. If the r is negative, very negative value, close to -1, suppose it is 0.96, so in this case we also talked that x, y are variable are highly negatively correlated. Also the last case, if this r value is, let's say, 0.02, then in this case also we'll talk that this variable x and y, so this is variable x and y, that will be there is no correlation if the r value is close to the 0. Okay, so these are the three cases we can have. Now let's us find out the correlation of this data. Now if x is defined, cap x is defined by this way and small x is this way, then this definition will be same as this one. So here the numerator is same as this one, but the denominator is changed to square root of sum of capital X square into capital of Y square, sum of Y square. So there is no small y is present in this definition. You can also simple mathematical calculation, you can find out how these, from these steps you can go from here. Okay, now let's find out the correlation of these two data x and y. So first we have to transfer this small xy to cap xy by finding the mean. So first we define this data, first data is x and next one is y. Now r I know, that is this definition. I have to find out what is the x bar, means the mean of x I have to first find out to change this to cap x. So small x bar, small x is this, all this variable, and x bar will be 8 plus 2, means sum of all the value. So 8 plus 2 is 10 plus 4 plus 6, that is 10, and 10, so 30 by 5, that is 6, so x bar is 6. Similarly y bar, that will be 7 plus 3 10, 4 plus 7 11, so 21 plus 9 30, 30 by 5, so 6, so y bar also 6, so x bar and y bar both are equal to 6. Now for all this correlation finding, we have to write down all the data in this way. So first we write x data in the first column, that is the small x data. Next column is for the small y. Next capital X is the small x minus x bar, means we are changing this by this way, right? By this formula is this way. Then capital Y is small y bar. Then for formula we required sum of cap y cap x. So here we are multiplying xy. After that we will find out what is the sum of this column, and sum of x square also required. So we will find out the sum of x square in this sum of all this column element of this here, and next one here. So first let's write down x variable here. So first variable is the 8, then 2, 4, 6 and 10. For y variable also 7, 3, 4, 7, 9. Okay, now I have to change the variable cap x. So I know x bar is 6, so 8 minus 6, that will be 2 here. Then 2 minus 6, that is minus 4. 4 minus 6 is minus 2. 6 minus 6, 0. Then 10 minus 6, that is 4. Now capital Y is y minus y bar. Y is 7. 7 minus 6 is 1. Then 3 minus 6 minus 3. 4 minus 6 minus 2. 7 minus 6 1. 9 minus 6 is 3. After that we have to find out the product of these two. So 2 into 1, that is 2, right? And 4 into minus 4 into minus 3, that is 12, right? And 2 minus 2 minus 2, that is 4. And 0 into 1 is 0. 4 into 3 is 12. And x square, the square of all these elements, 2, then it is minus 4 square 16, 2 square 4, 0, and last one 4 square 16. And y square also 1 9 4, right? 1 9, so 1 9 4. Then we have to find out sum of all these last three columns. So if I sum up all this one, then it will be 2 plus 12 14 plus 4 18, 18 plus 12, that is 30, right? And next column, that is 4 plus 16 20, and 20, and that is also 20. So this is the 40. And last one is 9 plus 1 10, and 10 20, and 4, that is 24, right? Now after that I use this formula, so 30 by square root of 40 into 24. Okay, so R will be 30 by square root of 40 into 24, that is 0.96825. So you can see R is very close to 1, right? So what can you say about x and y? So means that I can say that x and y basically positively correlated, very highly positively correlated. Okay, now let's have another example. Next example is that here the percentage of absentee of the absence of a student in a particular class, and there that is their corresponding grade point. Then I have to first write down what is the x. Let's say this is the x1 and this is the y variable. Okay, then I have to use the formula, the same formula we have used, the sum of capital X capital Y, the square root of sum of x square, sum of y square, right? And first we have to find out what is the x bar, like the previous way we have find out. So in this case it is 10 plus 20 30, 30 plus 30 60, and 60 plus 40 is 100, 100 plus 50 100 150, 150 by 5, that is 30. And similarly y bar, mean of y, you can find out sum of all this number by 5. Now we have to find out that cap x cap y. So x and small y are there. So x variable I just write down here, y variable all this one I write down. Then I change the cap x by using this formula, x minus x bar. So 10 minus 30 is minus 20, then 20 minus 30 is minus 10, 30 minus 20, 30 minus 30 is 0, 30 40 minus 10 10, and 20, right? Similarly 9 minus 6.6, that is 2.4, 8 minus 6.6, that is 1.4, 6 minus 7 minus 6.6, that is 0.4, and last will be this one. Now I have to find out the multiplication of this point. So I can see that it is minus 20 48, it is 1.4 into 10 minus 14 0, then it is minus 16, and it is minus 52, product of these two. And now x square, so minus 20 square 400, then minus 10 square 100, 0 100 400, right? Now capital Y square is square of all this, right? After that I have to find out sum of all these column here and sum of all this column, this one and last one. So I can see that sum of all this xy is this one, and sum of x square is 1000, and sum of y square is 17.2. I just put all this data here. So I'll see that r in this case is negative of 0.99. So I can see that x and y are highly negatively correlated. So this is also negative correlation is present, and the value of the correlation is minus 0.99124. Now third example. So we have the height of the student and the corresponding grade points. Now in this case I use the that same formula again every time. So here x bar I find out that is 60 and y bar is 7.6, right? Then I use that same column, 6 columns. How many columns are there? So here 7 columns. So x and y first column, then capital X is x minus 6 bar, so on, right? So I write all the x variable in the first column and y variable here, and capital X is this one, small y is this one, right? So 70 minus 60 10, then 65 minus 65, 60 minus 60 0, 55 minus 60 minus 5, and so on. Similarly y cap y. Now I have to find out the product, and lastly we have to find out the sum of all the column members. So in this case it is 0. Now see, here product of xy is 0. Now if I plug in here, then it will be 0. So whatever the denominator, so it is r will be 0. So r will be 0. So I can see that there is no correlation. So x, y, r is also called that 0 correlation or no correlation present between this variable x and y, and the value of the correlation is 0. Okay, so that's all for the today's lecture.